A few years ago, they had an intermediate value theorem problem on the AP exam, and it was really a pretty easy problem, but the function was not continuous. So you couldn't apply the intermediate value theorem. So you had to say that it did not apply because it was not continuous. So f has to be a continuous function on the interval that you're looking at. If it is not, nothing else that I'm talking about applies. Okay? So these definitions have all these letters that seem confusing, so we're going to kind of draw a picture for it. So f is continuous on the interval AB. So AB, those are going to be, A and B, those are going to be on our x-axis. So I'm just going to put an A here and a B here. Because our interval that we're given, that's going to be x-axis values that we're looking at. And so it says D is a number between f of A and f of B. Which axis are we going to find f of A and f of B on? When you find f of A, you take, like let's say we're finding f of 3. We take 3, we plug it into the equation, it gives us a number, maybe like 5. That 5 is our y-coordinate, right? The A is the x-coordinate, the f of A is your y-coordinate. So anytime you see f of A or f of B or f of 7, that's your y-coordinate. So I'm going to put f of A here and f of B here. I don't really know what they are, but I know they're going to be on that y-axis. And it also tells me that D is a number between f of A and f of B. So I'm just going to put a D somewhere like here. So right here, we've got to have the point A f of A. Right, if you plug in A, you get f of A. And right here, you have the point B f of B. Okay, so good luck, guys. So for this, it tells us the intermediate value theorem guarantees that there's at least one number C between A and B. So I'm going to put C here in a second. Such that f of C equals D. Actually, let me go ahead and put it on here. So C is between A and B. So C is somewhere here on this axis, on the x-axis here. So this is really a very simple idea. It's as simple as what we were looking at the beginning with the weight of the person. If you weigh 199 one week and you weigh 203 the next week, at some point you weigh 200 pounds in between that. So it's the same idea. So I'm going to put me a dotted line here just to show where the y value for D is at. And basically, all we're saying is that if you start off down here and you're trying to go up here and your function is continuous, then you've got to cross that line at some point. If you weigh 199 and up here you weigh 203, at some point you got to cross 200. Now, if the function is not continuous, this is not true. Because if the function is not continuous, then you could have something like this. You could have something like this, and it could jump up here, and it may never actually cross D. But in order for the intermediate value theorem to be true, the function must be continuous. So, I put my C in a bad place. Hold on. Let me draw this in again, just so it fits our picture. picture a little bit better. So right here, when I plug in C, when I find f of C, I get D for my answer right here at this point. Okay, so let's look at what actual problems will look like for this. So one thing that you're going to be asked to do on your homework is to explain why the function f of x equals e to the 2x minus 5 must have at least one zero on the interval from -1 to 2. Okay, so first of all, we need to know whether or not the function is continuous. Is e to the 2x minus 5 continuous? Let's remind ourselves and skip over here to Desmos real quick. Y equals e to the 2x minus 5. Look, continuous. And we're only looking, it does not have a vertical asymptote. It's just really steep right there. But even if it did, we're only looking from x equals, what, -1 to x equals +2. So we'd have to zoom out a little bit, but it's going to be continuous on that interval for sure. So here's what we're going to do. First of all, to do this correctly, and these usually end up on the free response section, not the, I mean, they're sometimes on multiple choice, but they like to put stuff like this on free response. So we're going to say, first of all, we must say f of x is continuous on the interval from -1 to 2. And so what we're going to say here, let me change my window so we can see this better. Let's make our window from -5 to 5 and from -10 to 9. Yeah. Okay, so there's a prettier picture. So what we're saying here for intermediate value theorem, let's see. Export image. So what we need to say here is right here at x equals -1, we're at this point. And right here at x equals 2, we're up here at this point. And to get from this point up to this point, we are going to have to cross that x-axis that lies somewhere in between. Right? So that's the idea that we're thinking of. So to prove that, because we got to prove it, we're going to have to find f of -1. Oh, let's see. Away from this and come back and see if it'll make it not do these crazy things that it does. Let's try again. F of -1. So we're just going to plug -1 into the equation. E 2 times -1 minus 5. And so this is not going to be something I can actually figure out. If this is calculator inactive, and this probably will be calculator inactive, this is not something I can figure out what the exact value of it is, but I can at least figure out whether or not it's positive or negative. So e to the negative 2x, how can I write that without the negative exponents? One over e squared, which is kind of like we did in the warm-up, right? Minus 5. Does anybody remember what the value for e is? Anywhere close to it? Like 2.7. I should know it further than that. Yeah, 2.7 something there. So what we've got here is like 1 over almost 3, let's say that, minus 5. Actually, 1 over almost 3 squared minus 5. So we're going to have something like roughly 1/9 minus 5. I really don't care all that much about exactly what it is, but I do know it's going to be negative, right? So that value is going to be negative. So let's find f of 2. And so for 2, f of 2, we would do e to the 2 times 2 minus 5. And so I get e to the 4th minus 5. And again, I really don't know what exactly that is. But e to the 4th, we're talking like 2.7 to the 4th power. So 2.7 times 2.7 times 2.7 times 2.7. Is that larger than 5? It is, right? I'm not sure how much, but I know it's bigger than 5. So that tells me this is going to be positive, which is good enough. Because they asked me if I had a 0 here, so that means the y-coordinate would be 0. So what I've got to say here is f of negative 1 is less than 0, less than f of 2. And I guess I should probably say since one of our zeros is negative and the other one is positive, and our function is continuous, that tells me, say or I guess we say by the intermediate value theorem. There exists at least one x on the interval from negative 1 to 2, such that f of x equals 0. Little did I know whenever I went to college, you go to college and major in math, this is what you do all the time. You don't even learn new math sometimes. You're just proving old math that you already knew how to do. So I've got notebooks of pages of, it looks like English, because you had to write all these sentences proving what you already knew. You knew that if he weighed 199 pounds here and 203 here, he weighed 200 somewhere in between. But we're required to be very explicit with all this, because in mathematics, you have to prove things are true using logic, and not just, oh, that kind of makes sense. It has to be proven. And so if you measure in math, you actually end up having to do a whole lot of that. I was kind of picturing myself just sitting around doing lots of long, fancy math problems all day, but it turned out to be a whole lot more of this stuff than I was really recognizing. But they do expect us to be able, especially for these theorems, to prove that these things are true. So the keys that you have to have here is that you have to say that f is continuous. You have to find f of negative 1 and f of 2. Sometimes they're really easy and you can find like f of negative 1 is 7 and f of 2 is negative 2. Sometimes you can find the values really easily. In this case, they were a little tougher to deal with. You must say that whatever value you're looking for, in this case it was 0 because we were looking for a 0 of the function or an x-intercept. You've got to say that that y value falls between these two. You must explicitly name the intermediate value theorem, because if you don't, especially on the free response question that I was looking at today, you don't get full credit for it. And then you must say that there has to be at least one x on the interval such that that f of x equals whatever value that you have there. Your wording can be slightly different in between these things. You know, you can use some therefores instead of such that's, and yeah, you can change your wording up a little bit. You can change the order that you state these things in a little bit, but all of those things have to be there for those. Okay, questions? Let's do another one. All right, so this one, on the interval negative 1 to 4, prove that the function f shown below, I should say for the function f, prove that for the function f shown below there is some c such that f of c equals negative 3. Justify your answer. Okay. So, first of all, f of x equals x squared minus 9 over x minus 5. It has a discontinuity. Where is that discontinuity going to be? It's going to be at 5. X equals 5, right? That's going to give us a discontinuity. So we know x, let's look back to the pen. We know x cannot equal 5. Is that in the interval that we're talking about? It is not. So, so for this one, we can say that f of x is continuous on the interval from negative 1 to 4. So then we need to find f of negative 1 and f of 4. So f of negative 1 is going to be negative 1 squared minus 9 over negative 1 minus 5. So we're going to get negative 8 over negative 6, which is 4/3. So our f of negative 1 is 4/3. And we also need to find f of 4. And f of 4, we're going to have 4 squared minus 9 over 4 minus 5. And so that is going to be 16 minus 9, which is going to give us 7 over negative 1. So f of 4 equals negative 7. So the first thing you have to ask yourself, the value they're asking us about is negative 3. Is negative 3 between 4/3 and negative 7? it fits between those, right? So you could write this a couple ways. You could say since the lowest number is -7, if you want to, you can say -7 less than -3 less than 4/3. Just use the numbers. Or instead, you could say f of 4 less than -3 less than f of -1. On the last one, I used the f of 1 and f of 4 because I needed to, because those values weren't numbers. But here, if you want to put the numbers, you can. Just make sure you have stated somewhere that f of -1 equals 4/3 and f of 4 equals 7. Since this is true, is it okay if I say IVT, intermediate value theorem? On the actual AP exam or your actual free response questions, write the whole thing out. AP should accept this because they use IVT in their solutions sometimes, but I don't know if they will for sure. So just to be safe, spell it out. Intermediate value theorem. So by the intermediate value theorem, there exists some C. I'm using C because they use C up here in the problem. Some C on the interval from -1 to 4 such that f of C equals -3. And as you do this on your homework, I do want you to write this stuff out, because I know it's a little annoying, but you'll have to on the problems that you see like this. Questions? All right, next one's multiple choice, so that's good. We don't have to prove anything. I'm also going to say this one is calculator active. So let me show you something really cool about these calculators. I love this. So it tells us let f of x equal x plus cosine of x over 5 minus 3. The intermediate value theorem applied to f on the closed interval from -9 to 4 guarantees a solution in -9 to 4 to which of the following equations? Okay, so what we're looking at is, first of all, is x plus cosine of x over 5 minus 3, is that continuous? Think of each piece. Is x going to be continuous? That's just a line, right? So that's continuous. Is cosine continuous? That's just a curve. That's continuous. Minus 3, constant function, also continuous. So putting all those together with plus and minuses, it's still continuous. Plus this would be calculator active, so you could graph it to see if it was continuous there. So this is continuous. And we want to know on the interval from -9 to 4, which one of these has to have a solution. So f of c equals -20, f of c equals 0, f of c equals 2, f of c equals 9. So if you think about that graph that we were looking at, actually, I need some over here on. We've got, over here is -9, over here is +4. And our f of c, our c is somewhere in between here. Our f of c is going to be somewhere on that y-axis. So we need to know what the endpoints of this look like. So look what the calculator will do. I think this is so cool. Go to y equals for me. Clear out anything that is there and type in this equation. Now, you don't have to do the problem this way, but it is time saving, especially if you have an even more complicated equation here. So, if I have typed this equation into y equals, I'm going to go back to the home screen, hit that home button right there underneath the green button. So, your calculator can basically do like function notation. So, if I type in just the letter y, which is right there beside your x, and 1, then it's telling it to look at whatever is in y1 in my y equals. And I'm going to do parentheses of -9. Kind of like doing f of -9, but I'm using y1 instead of the f because it's stored in y1. And so if you hit enter, actually probably green button and then enter. If you hit enter, you'll probably get crazy stuff. Hit the green button and then enter. That'll give you a decimal. So f of -9 is going to equal what is it, -12.2272. So that tells you you got a point at -9, -12 point something down here. Okay, did everybody get that to work? Okay. Did you get a number? Okay. What does it say? Okay, make sure that you just have the letter Y, the number 1, open parentheses, -9, close your parentheses. You, let's see. Did it work now? Okay, yeah. Be careful, that's easy to mess up. Alright, so, and then you can just type in y1 of 4, and it'll hit the green button before you hit enter. And it tells you y1 of 4 is 1.69671. So it'll plug it in for you. You don't even have to type the whole thing in. This is especially helpful if you've got a function that you're going to have to use for lots of things in a question. So I like that feature about this. It's kind of nice. Let's see. F of 4 is 1 point, what was it? 1.69. Give me one more decimal place at least. 671. So I have a point at -9, -12.2272, and I have a point at 4, 1.6967. So, at some point, do I have to have a f of c or a y value of -20? No, I might have you could graph this. It might actually go to that point because the graph might look like this. It might do something like this. We don't really know. But it's not guaranteed by the intermediate value theorem that it does that. What about f of c equals 0? It has to cross. I made bad answer choices here whenever I did this problem. Or actually, we can fix this. Guarantees a solution which applied to f on the closed interval guarantees the solution to all. Let's just change our question to all of the following equations except which one. So do you have to have a y value of 0? It's got to cross 0, right? What about 2? Okay, 2 would be right here. Is that between 1.6961? Oh, that's still got a bad problem. Never mind. It was fine like it was, wasn't it? I I was thinking negatives. I will not fix the problem. Okay. There we go. Okay. I deleted too much. Okay. Type was in line. Okay. So 2 is up here. It's above. That's not. We do not have to have that value. Also 9 is way up here, so we don't have to have that value. So the only one that's true there is B. So you have to have a y value of 0. Remember, when you're thinking of that f of c, any f of anything, that's a y value that you're looking at. Okay. Questions? Okay, so here's one that is like a multiple choice question that you may see. So f is a function such that f of negative 3 is less than 9, which is less than f of 6. Which of the following statements provides sufficient additional information to conclude that there is a value x equals c in the interval from negative 3 to 6 such that f of c equals 9? Okay, so for intermediate value theorem, if you think of what we have to prove, we have to, or what is here, we have to show that whatever value that we're looking for here is between two values, right? And those values have to be the endpoint of our interval. So that has all been shown here. What is the other condition that must be true? It has to be continuous. Oh, it shouldn't say constant there. I've lost my mind. Change that word right there to continuous so that there's a correct answer for you on your paper. Sorry, these are new notes and I looked back through them, but I'm usually going through everything pretty fast trying to get it done. So the f of x is continuous for x. It does not matter if it's increasing or decreasing. It could do either. Also, this one almost looks like it should be correct, except for I took the wrong. That should be negative 3 to 6. And that should be a 9. So sorry about those also, but there is a value x of c in the interval negative 3 to 6 such that the limit is x of c of f of x equals 9. That almost looks like it should be correct, but it doesn't have to be continuous for the limit to exist. Will you mind letting me in? Thank you. The function doesn't have to be continuous for the limit to exist. So while that might be true, it doesn't have to be true for this to be the case. Immediately disappeared as soon as the end. I'm not sure. Okay. All right. So here's our last one. On the interval from 0 to 4, the function f shown below must have a value x equals c such that x squared minus 3x plus 2 over x minus our function is f of x equals x squared minus 3x plus 2 over x minus 2. So which one of these has to be true? F of c equals negative 5, f of c equals 2, f of c equals 6. Take a second and see what you think about this one. For the sake of time, you can use your calculator if you need to. I was not recording that last problem. The answer is D because you have a hole in the graph on this and it's not